Hey guys, how's it going? So today we're gonna go over this concept of structural realism. Um, to be more precise, we're gonna go over this idea, something called ontic structural realism. Okay. So first, before we formalize this the thesis of ontic structural realism, um, let's maybe go over some basic ideas. So what is a relation? According to, I don't know, textbook example, right? A relation R, right, is supposed to be some sort of n array um, between uh, wal walata, relata. Um, Take, for example, let's say you have a node A, we have a node B, there's a relationship here connecting A and B. Now, we could denote this by something like R, A, and B, where in this case, A and B are the nodes. Okay. So oftentimes some scholars would say relation is the same as, or they would put it in a way like properties. They would say that it's a properties of properties, which is kind of vague, but I think it's good to analyze what that means. Um, Properties of properties. So, what is the property of a property? A property of a property would be an example of relation between properties, right? I think a good example would be, well, the way we can kind of imagine this is that suppose that we have, say, P of X, where that means that we have an object X with the property P, and we have a object Y with the property Q, right? Then a relation is a relation between P and Q. Relation here is R is the same as relation between P and Q. Without regard to X and Y, we're not gonna, focus on X and Y. Now there is some people who make the formula. Some people would define um, would specify relation also specifying X and Y, right? So some people would say that actually, yeah, forget that about that. I think it's called structure. So another maybe a graphical way of representing this would be to say that so suppose that this is X. X is an of course an object. Suppose that we have Y. So this is P of X. This is Q of X, right? So let's draw a line. So what is the property of X? Well, the property of X is P. What is the property of Y? The property of Y is Q. To say that relation, uh, to say that there is a relation between P and Q is to say that draw a line, is to say that there is an edge between P and Q, where the edge represents a relation between P and Q. So this represents this thing, relation between P and Q. I think it's good example, good now to kind of do some sort of practical examples maybe. A practical example would be to say that consider the following. Let's say John. Let's say we have X is John. And let's say that P is, let's say in this case, has a property of has a PhD degree. Okay. And let's say Q in this case is the property of wrote a paper. Okay. So surely someone who have a PhD surely has done so because they have written a paper. So there's nothing contentious about, P of X. Well, X is John, P of X is connected to Q of X, right? But in a certain sense, we don't really need to have X. Well, we don't need to have John here because it could be anything. It could be Mary. It could be, Jonathan, right? What is really the the important thing is that there is a connection between the property of having a PhD and and having written a paper. So forget about the X. Instead, there's a connection between P and Q, right? Namely, anyone who has a PhD surely also have written a paper. So in this case, it is represented by R, P, and Q. And this is what we mean by property of properties or relation. Let's give another example. Let's say we have P be the property of has a job. Has a job. And let Q be has a paycheck. Now, I don't need to specify who has a job and who has a paycheck because it really doesn't matter, right? Because anyone who has a job surely has a paycheck. And if you have a paycheck, surely you have a job. It doesn't really matter who has a job or who has a paycheck. There is a connection between the property of has a job and has a paycheck. So P is connected to Q, right? So it can symbolize this relationship with a relationship called R. R is this relationship, unique relationship between the two properties of has a job and has a paycheck. Now we come this far, and so we talk about relationship, right? Relationship as okay, we talk about relationship R as represented by nodes, right? Let's say, okay, sorry. We talk about relationships as relationship between properties like P and Q, right? So we can generalize from this to say that, yeah, let's forget about P and Q. Let's focus on, in general, let's talk about a, let's talk about relation in the abstract, right? So a relation in this abstract, we can think of it as a relation of R1, R2, R3, etc. Maybe it's finite. Let's say relation Rn, where each R sub some number represents a relation between, say, two properties, right? Now, we can define such a structure to be a structure. So let so what is a structure? Like, okay, so we're gonna define this new term, this new object, a structure. A structure S is basically um, just the set of all relation that define the structure. Now, some commentators or some logicians would say that, well, yeah, it's not just the relations, you also need the nodes as well. So the you know, so some people would say that, well, you need to define S, and in this set, you need to have the set D, where D represents all of the elements, um, like for example, John or Mary or Bob, for example, and then a set of relations. Um, for the Ontic structural realists, um, it D isn't what is important. Um, in fact, for the Ontic structural realists, D can be done without, right? So now we could, like, maybe we can just give an example of a structure, for example. Um, yeah, so let's say we have the structure. Let's say give an example of a structure, right? So let S be um, A. So there's an edge between the node A and B, B and C, and C and D. And this is the structure. So you have A, you have B, and you have C, and you have D. AB is connected, BC is connected, and CD is connected. Okay. So immediately we see that the nodes A, B, C, D, A, B, C, D, it could be anything. It could be A could be cat, B could be boy, and C could be dog, and D could be car, right? They're related in some ways. So what is important isn't really the nodes themselves, according to the Ontic structural realists. What is important is the relation between the nodes. So what the Ontic structural realists take to be primitive is really just these relations, right? So what is really so take this is going to be R1, this is going to be R2, and this is going to be R3. So for the Ontic structural realists, on R1, R2, and R3 are primitives. And fundamental. The nodes are not fundamental. A, B, C, D are not fundamental. Are not fundamental. So we now have a picture, right? Where given given uh, given the set of relation, right? R1, R2, R3, etc. We have a structure. We have a structure. S. Namely, S is just the set of relations. Now, some commentators, they would say that S needs to specify also the domain of the elements like A, B, C, D, right? But for the, like, for example, but for the Ontic structural realist, what is important isn't really the elements. In fact, for the radical structural realists, um, it really doesn't matter at all. They would say that D is the null set, namely there's no element in that set. So for the Ontic structural realists, well, this is the way to go. Ontic structural realists. Um, yeah. So yeah. So for the Ontic structural realists, only the relation is what matters. The things are not fundamental. And given the relation, you automatically have the structure. Maybe a technical point that I want to point is that there's some sort of asymmetry there, right? Namely, for example, given the relations, given the relations, given the relations, we have the structure. The converse is not true. It is not true that given the structure, we have the relations. So this is a technical point, and it's something that I can go over next time. Okay. Um, um, Also, for the radical, so there are some for the Ontic structural realists, there are various grades of it. For the radical Ontic structural realists, right? Um, uh, um, so for the radical Ontic structural realists, we don't need things. We don't need uh need, need things. Things. So remember, things is attached to a property, right? So when we talk about P of X and Q of Y, right? Well, X and Y are things, right? We don't need that. For the for the radical Ontic structural realists, yeah, X, Y are, we don't need that, right? All we need is P and Q, okay? Or more precisely, we need with the relation between P and Q. And more precisely, um, the universe is just relations. It's just relations without any relata. So relata is things like X and Y, right? So for the radical Ontic structural realist, the universe is just relations, primitive relations, without any relata, without, like, for example, X and Y, right? We don't need John and Mary. Give me the relation and I give you the world. Basically, that's what the radical Ontic structural realists say. Um, but if you're not an Ontic structural realist, um, you can have so suppose you're not an Ontic structural realist, not So you're not, if suppose you're not not radical on the structural realist, right? Um, you um, uh, there is still a commitment. There is still a commitment to relata. Relata. I don't know. It's like X and Y, or Mary and John, etc. All right. All right. Thank you. All right.